Hi everyone, welcome to my channel. The topic we are looking at this time around is refraction of light passing through glass prisms. Though we are considering the calculation that are related to this topic, but just before that, let's quickly consider some definitions and parameters that has to do with reflection of light through glass prism. What is refraction? Refraction is the bending of light ray as it crosses the boundary between two media of different density, thus causing a change in its direction or wavelength and the speed. Okay, now let's quickly see refraction in rectangular glass prism because we have two types of glass prism that we are going to consider in this topic. First one is rectangular glass prism. So let's see how light is refracted in rectangular glass prism. Here is a picture of a rectangular glass prism. As you can see, we have a rectangular glass prism, and let's say this is the incident ray coming into glass prism, and this is normal. I believe we are a bit familiar with these terms from video on plane mirror. So we have normal. So the angle between incident ray and normal is called angle of incidence, represented with a small letter I. And as the light passes through the glass prism, due to variation in density of the incident medium and refractive medium, the medium here is air, while this place is glass. So due to variation in the density, the path of the light changes as it crosses the boundary from air to glass. And we can see that this is the original path that it's supposed to follow, but it has bent towards the normal. That is what normally happens when light travel from less dense medium to a denser medium. That is, air is less dense compared to glass. When light travel from less dense medium to denser medium, it bends towards the normal, and that is what happened here. And when that happens, we'll say refraction has occurred. And at the same time, when light is coming out from the glass, going back to the air, we can see the light bending away from the normal. And the angle that the uh, light that is refracted through the glass is making with the normal in the glass is called the angle of refraction, while the angle that it makes with normal when going out of the glass is called emergent angle. Now the angle between the original part of the glass and the refracted ray, that is known as angle of deviations. These are all the terms that we're going to be considering when we start having calculations on this. Okay, let's quickly check triangular prism. The picture here shows the path of light through a triangular glass prism. Okay, now this is our incident ray, and this is our normal represented with n, and the angle between incident ray and normal is known as incident angle, as we can see there. Now this original path that the light is supposed to follow if there is no refraction, but due to variation in density of air and glass, we experience refraction. This is glass, and according to what we've seen in a rectangular glass prism, when a ray of light travels from less dense medium to denser medium, it is refracted towards the normal, and that is what happened here. It bends towards the normal, and as it is going out of the glass, it bends away from the normal, as you can see here. So similar to what we saw in rectangular glass prism, the angle between refracted ray and the normal here is known as an angle of refraction, and also the angle between the ray that is coming out of the glass and the normal on this side is known as an emergent angle. And also we can see the original part. The angle separates the original part, and the rays that emerges from the glass we call the angle of minimum deviation for the triangular glass prism. This triangular glass prism is equilateral triangular glass prism, and in most cases all its angle is equal to 60. That is A equal to B equal to C and is equal to 60. That is what we are saying. So A is known as a refracting angle of the prism. We have I as incident angle, R is angle of refraction, D, capital letter D is angle of deviation, and E is known as emergent angle, and A is what we can call a refracting angle of the prism. Okay, let's quickly see some other parameters before we go into our calculation. There's law governing the path of light through glass prism, and one of them is we have laws of refraction, but we are going to consider only one that is also known as Nernst law, which states that the ratio of sine of angle of incidence in the first medium, that is in the incident medium, to the sine of angle of refraction in the second medium, which is refractive medium, is constant for a given pair of media, and that is what we can see in this equation here. That is sine of angle of incidence over sine of angle of refraction is a constant, and that constant is known as a refractive index. And due to we are dealing with two media here, the first and the second media must have their different refractive indices, and that is why this refractive index here is equal to this. But from the part of Snell's law, from its own perspective, Snell's law consider light traveling from air to the glass or to any other medium, and the refractive index of air or vacuum is 1. That is why Snell's law limited his own equation to this. But the actual equation for this statement is refractive index of where the light is going to, that is refractive medium, over refractive index of incident medium equal to sine of angle of incidence over sine of angle of refraction. That is the original equation. So that is why we said that this is equal to the whole of this. Okay, now, and for triangular glass prism, due to some other parameters that we discussed in triangular glass prism, that is refractive angle of a triangular glass prism and angle of deviation, this Nernst law is expressed in this form for triangular glass prism. So when we get to calculation, we're going to see how to apply all these parameters in solving problems. Okay, now what is refractive index that we just mentioned? Refractive index, which is represented with this symbol for a medium, is the extent to which light is refracted when it enters the medium, or we can define it as the ratio of the speed of light in air or vacuum to the speed of light in a given media. As we can see here, that if we can see the speed of light in air or vacuum divided by the speed of light in a given medium. That is another definition for refractive index, and it can as well be expressed as the wavelength of light in air divided by wavelength of light in a given medium. Okay, moving away from that, let's quickly consider some examples and use all this explanation in solving problems. Now, the first question says, a ray of light is incident at an angle of 45 degrees on a rectangular glass prism from here. We have to calculate the angle of refraction and the angle of deviation D in the prism. Okay, from the question, our I, which is angle of incidence, is given as 45 degree, and we have the refractive index of the glass as 1.5, and without giving, we also know that the refractive index of air is 1. That is, refractive index of air or vacuum is equal to 1. Okay, now we have to find the angle of refraction. Okay, using this Nernst law equation, we have this, and we can make our sine r the subject of the formula, as we can see here. So from there we have our sine 45 divided by 1.52. Okay, sine 45 divided by 1.52 is equal to 0. This will give us 0.4652. And to have the value of our r, we need to find our sine inverse of 0.4652. On your calculator, what you just need to do is press shift sign and type this number, and just press equal to. That will take us straight away to this, and this simply means that the angle of refraction through the glass is equal to 27.7 degree. And mathematically, from the ray diagram that we check for rectangular glass prism, let's quickly go back there. We can see that I equal to R plus D, but let's quickly go back and check that. Okay, let's go back and see that. Okay, now from what we have here, mathematically, we can see this angle equal to this angle, that is a vertical opposite angle, are equal. So we can say I equal to R plus D mathematically. So that is what we are going to use in solving that problem in example 1. Okay, so we have this here. Okay, now solving for D, we can say D equal to I minus R, that is I equal to R plus D, and that takes us to this place. That is why we subtracted our angle of refraction from incident angle, and we have our angle of deviation to be 17.3. Okay, now moving away from that, let's go to the second example. In our second example, we have the angle of incidence of light on the face of equilateral triangular prism is 46 degree. We have to calculate the angle of minimum deviation and angle of refraction, also the refractive index of the material of the prism. Okay, now from here, let's quickly check the Snell's law and compare for rectangular and triangular glass prism. Okay, if you look at this part, Snell's law, sine I over sine R equal to refractive index. If this represents refractive index and this is also refractive index, we can see that mathematically sine I will be equal to sine A plus D over 2. That is, this sine I will be equal to sine A plus D over 2, which means we can say I equal to A plus D all over 2. Also, we can say R equal to A over 2. So let's quickly see how we can apply this in solving the problem in second example. Okay, let's go back to second example. As we can see from Snell's law, we can deduce that our I equal to A plus D over 2, and that is what we use here. Our I equal to 46, A, which is refracting angle of our equilateral triangular prism, equal to 60 degree because it's equilateral triangular prism. All angles are equal. Okay, and with this equation, we substituted these parameters in our equation here, and we are able to get 92. That is, if you say 46 equal to 60 plus D over 2, you can easily cross multiply by having 92 equal to 60 plus D. So your D will be equal to 92 minus 60, and our angle of minimum deviation equal to 32 degree. Okay, in question number 2, we as well substituted A over 2 for R. That is, we equate R equal to A over 2. And A, according to the question, is 60. 60 divided by 2 will give us 30 degrees. So that is what we did here. Okay. Moving to the third part of the question, we have to look for refractive index of the glass. Remember that in Snell's law, we have refractive index equal to sine I over sine R. and that is what we use here. We've gotten our R already, and we have our I from the equation, and that is what we have here. And pressing this on calculator, we have 1.44 as the refractive index of that particular glass prism. Okay, let's check our third example. Now let's check our third example. In third example, we have a beam of light traveling from a vacuum at 3 times 10 raised to power 8 meter per second, that is at speed of 3 times 10 raised to power 8 meter per second, and enters a glass of refractive index of 1.52. We have to determine its speed in the glass according to the relationship. Remember the refractive index equal to speed of light in air or vacuum over speed of light in any given medium. So making speed of light in a given medium subject to the formula, we have speed of light in air over refractive index, and that is what we did here. We substituted the values, and we have the speed of light in that given medium as 1.98 multiplied by 10 raised to power 8.